So, as many of you might know, that problem solving is a really important thing for DSA. And when we approach a question, then there should be three main approaches. One should be brute force, second should be better approach, and third should be optimal approach. These three approaches can tell the interviewer about your problem solving skills and tell you about how to actually approach the question. Now, let us discuss the first part, the brute force approach. Now, you might ask, why the brute force approach? Where very simply, if the brute force approach is told by you, then A, it lays a foundation for the interviewer as well about your basic knowledge instead of just mugging up the optimal solution and telling that that's wrong. You should use a brute force approach first and then build on it so that you can easily showcase your problem solving ability and tackle a new question if you have not actually done that question previously. Now let's come to the how part. So many people struggle in how to actually start with a question. So this is a very new technique that I am trying to like showcase here. So hash method is the technique's name, in which it is just an acronym. The H stands for hashing, a very basic operation that we do. Then arrays, the different type of arrays, then the different type of operation that can be done on an array can be used. Then sorting, and then heaps. Now let's one by one understand how hashing and arrays and sorting might work out. So as we know that hashing is a very basic concept, and hashing can help us with the O of one operations for insertion, deletion, and finding, etc. So these are divided into two parts, hash map and hash sets. We will be discussing that forward. Then we have arrays. Now after doing the hashing part, as hashing is a O of one operation, we can just move on to arrays as it is an O of n operation for generally uh, addition and deletion of insertion and deletion of elements. Then we can go to sorting. Sorting is a very essential thing because it can be used to actually apply binary search. If you sort an algorithm first, if you sort an array first and get the solution, then it's not the optimal approach, but it can be a starting point for your solution. Then coming to heaps. Heaps are very much related to sorting. If you're only able to do sorting, then only you can use heaps. If you are not able to do sorting, then no need to use heaps. Heaps can actually prevent you from using sorting because they are a data structure that can be much more optimal and have inherent sorting built into them. So I guess that would be it, and we will be moving on to the hashing part. So hashing is divided into two parts, hash maps and hash sets. Hash maps are those, basically, if you have experienced dictionaries or like a unordered map, we can see that they are very much an implementation of the hash map concept. So basically, there's a key and then there is a value. The key and the value are corresponding to each other. You can define it as a function in which you have one object pointing to another object. This you have done in mathematics also. Whereas hashing, if you actually look on the internet, it's very complicated and it involves modulus and some other operator, then memory allocation. You don't always need that because if you do hashing and you're just doing problem solving, you can just use the concept of hash maps. Then coming to the hash set part, this only stores a frequency of 1 for every value. And it's basically a set in maths which contains a collection of values. That's it. Now, let us actually look at some examples for the questions. And first of all, I would like to introduce you about what is the general like usage of hash maps. Like in Python, we use curly braces, and then let's just say there is a key, and then there is another value. So this is a hash map. We can always use default dic also in Python to define something for a dictionary or a hash map. As we say in Python, it's a dictionary. Whereas in CPP, we have unordered map which has two values. The first is a key value and the second is the value. And Java is very much similar. You have to just, look up the syntax in the Java machine language and just declare a new hash map. So now coming on to this question. This is lead code question number 217, contain duplicates. So if we apply a brute force approach, obviously there might be other optimal approaches, but if we apply a brute force approach to this, we will use our hash method. See, okay, H is standing for hashing. And then we are just looking at a hash map for this question. So applying a hash map for this question, I will just do it in Python. You can see that a value is repeated in this question and we just have to return if a value is actually repeated. So it is a basic frequency count. You can obviously go through the whole array, have a duplicate value and do some sort of other thing. But if you're doing the concept yourself, then use the hash method and just start with hashing. So first the value of 1 here is 1, then the value of 2 is 1, then the value of 3 is 1. But again, we go to this value and check, okay, it's 1 already. So we just update the value to 2. This is our final hash map. As you can see in this case and this case, we have for case number 1 and case number 2. Then we can just go through this whole hash map and get the frequency of 2, or it says at least 2 times. So it should be greater than 1. That would be an answer. So here you can see this is a CPP implementation of this code. You can just write in Java or Python also. That would be much easier. And you can just write the unordered map and then name of the map. Use the whole array that has been given. Then add the array as a key value. Remember, the array elements are the key values and the value that is actually being stored is the frequency. So the frequency will just be incremented by 1. And obviously all the values are initialized as 0. So initialization at 0 is occurs. And then we are just looping through our hash map or our nums array. We can loop through our hash map also and get the whole hash map. That would be much easier. Otherwise, another approach can be there, which we have taken in this question, is to just loop through the array again and then find out which is greater than 1. As mentioned previously, we can see that this is greater than 1. So we just output that it is true and there is a duplicate element present. So the time complexity for this approach is O of n, and the space complexity for this approach is also O of n, because we are reducing a hash map. So we will obviously use some extra space, and for the worst case scenario, if all the values are there and we have to store them, then it is O of n. Then moving on to question for hash set. Most people generally tend to use hash map a lot more because when you have a hash map, then you have much more control on your whole uh, hashing scenario and the whole array. But sets are also really easy to implement. And if you actually don't care about the frequency and uh, the values that are being stored, and you just want a list of the elements that are actually occurring in the array, where in this question we would actually want that. So that would be a simple approach. Now you can just read this question once and we can try to implement it using hash map. So it says that there is an intersection of two arrays. So instead of arrays, use sets or some other imaginary data structure which only has once occurrence of all elements. Because an array might have repeated elements, you can obviously use a hash map in this also, but it might complicate the things. So once in an element, because in an intersection, the number of times do not actually matter. The frequency does not matter. So if we look at this question, we just need to produce an array with 1 comma 2 or all the unique element, and then for this array we will just produce a 2, and then we will find an intersection that would be 2. Similarly, for this question we can look that there is an array and then there is another array. We just find the answer is 4, 9, 5 for this, and then we find that the answer for this array is 9, 4 and 8 for this, and then we find the intersection between the two, and when we get the answer 4 comma 9 or 9 comma 4, it's the same because we have to return the answer in any order. So you can see that we have done the same approach here. So as we are taking this first step and then we are taking the second step for insertion, first step can be easily done using hash set. No need to use hash maps. So this is the coding implementation where we actually make a hash set out of our nums1 array and just make it set number 1. Then we have another set which is set number 2 out of our nums2 array. Simply we are applying this part. This is our set number 1 and this is our set number 2. Now having two sets, we have to find an intersection. So we can just iterate through the first set. Loop through set number 1 and get the value. Find it in set number 2. If it only exists in set number 2, then we are pushing it back into the resulting array. Simple. And we can use another way to actually write it. In Python or JavaScript it might be easier, but in CPP you need to implement this line dot end to signify that our set has not ended and we are not out of the set. Because if we are out of the set, then it would indicate that your set is in that your number that you have found is invalid and you might have skipped a set. So this is the basic pointer or basic points that we need to keep in mind while implementing any kind of hash set question. So now coming on to the time complexity, it's O of n again because we have to go through the whole set number 1, which might have all the unique values of nums of 1, where there may be n elements, and then those n elements will need to be reiterated in terms of the set number 1 and getting the time complexity 1 and O of n. Then we are getting the space complexity is equals to O of n if there are a number of distinct values, and then we get the O of n complexity. I guess that would be it for today.